All right, create expression tree. This is going to be the fun one. So this is where I'm actually going to follow this algorithm here and walk through everything. So building an expression tree, the first thing I'm going to do is I'm going to take whatever the text is, the input, and add an open parenthesis to the beginning and a closed parenthesis to the end. Go ahead and assume that everything is the correct format for now. You don't need to worry about they gave you garbage input. So let's see. First of all, public is going to give back a binary node because I want to eventually assign it to the root. Create expression tree. It's going to take a string coming in. This method creates an expression tree using the input The input is assumed to be an expression in Infix notation. So we're assuming they're doing 5 plus 3, not plus 5, 3, or so on. So the first thing was, let's see, we're going to assume that the first thing is a string in Infix, and we want to add a parenthesis to the beginning and end. Well, that's easy. Input equals open parenthesis plus input plus a close parenthesis. Done. So that was the first step. So now we're going to read in one token at a time is what we're calling it, basically one character. So I need to read in a particular character. So I guess I will call this token index. Starting at 0, I'm going to keep going while it is less than input.length. So keep going while there's more things to read in my input. Add one each time through it. All right, so this is going to go through and follow this algorithm, and eventually I'm going to return a node here. Now I haven't actually created one of these stacks yet, so I need to do that. So let me create a node stack before I get too much further into this. And then when I'm all done, the last thing that should be on there, once this algorithm is done, is the only thing left is the root node. So I can just return whatever is left on the stack. All right. So popping is how you get something off the top of the stack. So to begin with, what do? So I make a node, which is the current token. Got it. I can handle that. Binary node token is what? It's going to be a string, and it's going to be the current character that I'm looking at. So I need a new binary node, and I'll pass in, well, it's a string, but it's going to be a input.charat token index. Okay, so I have a new node named token, which is this thing here. If the token is a less than sign, push the node. Okay. If, you know what, I'm going to be using that particular character over and over again, so let's actually just grab a hold of that guy. The char, let's call this token node and call this token. And this dude here is the character that I'm looking at, and I'll just add on token. So you notice that once I noticed that I was going to have a pattern over and over again, I pull the pattern out to something that shortens it, and then I can use that in my expressions. This is a useful skill to have. Once you realize that you're going to have a pattern over and over, try and simplify it. Okay, so I have this token, and I say if token is one of those, we're going to push on the token node. Done. All right, so that's the first step. So if it was a less than sign, we just push it. If it's a number, how do we figure out if it's a number? So token is a character. I don't know if you remember some of the things from character, but there's a one which is called isDigit. Digit. So now we can check that. By the way, I could say equals equals true, and that's what I've been doing in the past. It turns out, though, that if whatever the expression is within the if statement evaluates to true, that's the same thing as saying equals equals true. So I actually don't have to explicitly say that. Another thing I could say is if I want to say if it's false, I could just put a not at the front of it, and that does exactly the same thing, only I'm saying equals equals false. So sometimes that's a shortcut you'll see. All right, let's say it's a digit. What happens then? We should look and see if it's an operator. Ooh, how do we tell if it's an operator? I think I'm going to actually create a special method for this. Public Boolean is operator. I'm going to take a char, token, why not? Notice, by the way, this token in here is different than this one up here. They are named the same thing, but they're actually referring to two different things. This is whatever's in the parentheses of is operator. This one is within this for loop here. You are allowed to use the same name multiple times as long as they don't overwrite each other. Okay. If token is a plus sign, or token is a minus sign, or token is a times sign, so the star is times in our stuff, or token is a /, which is divide. Return true. Otherwise, return false. So now I can say if stack.peak, so that's this guy here, we're going to peek at what's on top, and we want to check to see if that's an operator. So peek will give us back a node. Okay, we want to look at what its value is. Get value. All right, that's a string. I need to hand it a char. So I can say, since there's only one thing in there, char at 0. So if that whole thing is an operator, then I want to do something with it. So what was the thing I wanted to do? If peek is an operator, I grab onto the node that's on top. So binary node operator equals stack.pop. Okay, so op equals pop. Make the node that I currently have, that's this token node, the right child of this operator, and then push the operator back on. Dot set right token node stack dot push operator. Okay, so I grab the top of the stack, I make the current thing that I'm holding onto the node the right child of that thing, push it back on. If not, I just push it. Stack.push token node. All right,